Next step here is to take the inverse of a function. So same principle applies where we're going to flip x and y, but obviously it's not a table of numbers, it's an actual function. So the first thing you're going to do is rewrite the function as an equation. So instead of function notation f of x, we're going to replace that with y. Then you flip where the x and the y are. So y equals x squared would become x equals y squared. And then you solve for y. So in this case, the inverse of f can be represented by the algebraically by the equation y equals plus or minus square root of x. Now we're looking at the graph of the original and the graph of the inverse. So the blue is the original, y equals x squared. The red here is the inverse, so y equals plus or minus square root of x. The plus would be the top and the minus would be the bottom, by the way. The inverse is not a function because it would fail the vertical line test if you were asked that. They also are symmetrical about the line y equals x. So if you flipped it across the line y equals x, that curve is the same shape, right? It's just flipped over the line y equals x. All right, so this one, give it a try. So pause it, try it, and then come back. All right, so for the first part here, I rewrote f of x equals 2x plus 1 as y equals 2x plus 1. Then I flipped the x and the y. Then I solved for y. So the first thing I did was subtract 1, then I divide it by 2, and then I find out the fractions. So x over 2 is the same thing as 1/2 x, and negative 1 over 2 is the same thing as saying minus 1/2. So how can you determine if that is a function or not using a graph? If you graphed it, you could do the vertical line test. This is a line, so a line will pass the vertical line test unless it is a vertical line, which obviously this is not. So this is a function, and that's how you could tell, is basically graph it, do the vertical line test. All right, let's check out example 3.